Right, hi Ari. So question 28 of the analysis non-calculator. Um, okay, so here we go. I've written out the 6 functions and we're going to have a look at them one by one and then try and match them up with the graph. So we're going to start with that. So we've taken ln x, the basic to this, if it works. Oh, can you not do it? Hang on. Yeah, okay, so there's ln x. And we know that if we change the x for the x1, it's like moving it left. So if I change that to +1, there we go, moves it 1 to the left. As long as I know what ln x is like, and it moves it 1 to the left, then that looks pretty much to me like graph 4. So I reckon that that's the easy one, that's going to be graph 4. So let's go to this one, and where are we? Stick here, big 4. Alright, so 1 down. F2. Whenever you get this going on, this ln of x plus or minus a ln 2x minus 1, factorize it first. So whatever you times the x by, take that to the outside of a bracket. So change it into the form there where it's ln 2 brackets x minus a half. If you expanded those brackets, you get a real function. Then it's slightly counterintuitive. Okay, it's a bit weird, and it's because we're so used to doing BIDMAS and doing the stuff in the bracket first and then do the multiplication. But in this case, the transformations, they happen the opposite way. So here we're going to do we're going to start off by changing it to ln 2x. So that's going to be a horizontal stretch of scale factor of half. Let's go and have a look at what that would look like. There's my cursor gone. It's disappeared completely. Oh no, there it is. Right. So we'll just tab down and have a look at this. I don't know why is it not doing it. Oh yeah, there we go. It's just a bit slow. Okay. There we go. Right. So horizontal stretch scale factor of half would look like that. Yeah, instead of going through 0 at 1, it's going to go through 0 at half. And then the second part of it is the where are we? This one would be, then you do this minus a half, so that's a translation of a half to the right. So it's slightly out of order. You do the horizontal stretch first, the times 2 bit, and then when you've done that, then you do the horizontal translation to the right. So that would change it to. Let's work, yes. Okay, which would look like that. So, so that is looking like graph 3. Like graph 3, so I think we've matched that to graph 3. So let's go back here and label that. So we've got 2 of them done already, fantastic. Alright, F3, we're going to do the same again, and we'll just talk about what we do. So we factorise it, we take this half to the outside of a bracket, half bracket x minus 2, because if I expanded this I'd get back to this. And as long as it's in this form, then I know it's going to be a horizontal stretch scale factor 2. So that's like going to take it and stretch the graph. So instead of going through at 1, it's now going to go through at 2. You go through 0 at 2, and then it's going to be a after that it's going to be this minus 2. So that's going to move it 2 to the right. So that means that the 0 was going through at 1 to start with when it was just ln x. Then we did the horizontal stretch, which made the 0 go through at 2, and then we moved it 2 to the right, which made the 0 go through at 4. But there are no graphs here, like 1, 2, 3 and 4, none of them go through at x equals 4, so that's nonsense. So that's not going to be one of them. That's going to be okay, so let's get rid of that one, and you can just have a look at that in your calculator if you want and see what I mean. Then a bit of a cheeky monkey, this one, because look, I've started off with ln e squared times x. I can use my log rules. If it's those two things times together, I can split it so it's ln e squared plus ln x. I can move the power of 2 down, so it's 2 ln e plus ln x. But ln e is 1, So 2 times 1 is 2, so that becomes 2 plus ln x, or ln x plus 2, either way around, which is exactly the same as f6. I think they're being a bit cheeky there, if you ask me. Ln x plus 2 is just a vertical move upwards of 2 places, and if you have a look at, which one was it? Yeah, graph 1, you can see it goes through the point 1, 2, whereas where it was going through the point 1, 0. So you've taken the ln graph and moved it 2 places up. So both of those, f4 and f6, are going to be graph 1. So I thought that was a bit harsh actually, but there we go. That's what they're giving us. So there we go. So that's going to be graph 1. Alright, so we're pretty sure now, we've only got one left and one function, so I'm pretty sure this is going to be graph 2, but let's just have a look and check. First of all, it's 2 minus x. That's exactly the same, because I've got minus 1 lots of x, so I could write that first, minus x. And then, although we're a bit lazy and we don't write it, it's the same as minus x plus 2. I could switch it around like this. I could factorise it. It's minus 1 lot of x there, so I'm going to take the minus to the outside of a bracket, minus bracket x, minus 2, minus of a minus will give us a plus. So that means that I need to, it's ln minus x to start with, times it by minus 1, that's a reflection of the y-axis, it's like flipping it around the y-axis. It's going to make it go the other way, which is already fits in with what graph 2 is telling us. And then, after you've reflected it, you move it 2 places to the right, the thing in the bracket, which would take it from going through minus 1, 0 after the reflection to going through at 1, 0 again, which is exactly what happens with graph 2. So I think that's okay for graph 2. So there we go. There's the 4 things matched up. This thing's a bit nasty, I think. So you know, if that, you know, I suspect a few of you wouldn't have spotted that. But there we go. I hope that's enough. Oh, by the way, you asked about answers in one of your last one of the comments in the spreadsheet. I'd say all the non-calculated questions, do them on your calculator and get the answers that way. So for example, that one with the mean, do it on your calculator and make sure that works. And then, because it's good practice for your calculator, and we're doing all these videos, I haven't got much time to do all the answers as well. So, you know, as I say in general, if it's working, then that's okay. But yeah, check out your calculator. All right, bye bye.